Welcome back, chemistry fans. I am now going to go over the free response questions from the Unit 4 exam. I will start with what I believe is question number 13, 14. I'm not sure. So let's see where we're at here on this one. It is 14. Okay. So in this question, we are asked a nuclear question. It says uranium-235 is fused with one neutron. So we're going to have to write this out. 235 uranium, which is element 92, it's fused with a neutron. Neutrons have a 1, 0, and the products are 3 neutrons. Krypton, which is element number 36, and something else. That's what we're looking for, is the something else. We don't know what that is. So over here on the left side, if I add those together, I've got 236. Well, I need to know that on the right side, the 236 is what it must equal also. So I have 3 with the neutrons, and I have 94 with the krypton, so that's 97. So 236 minus 97 gives me 139 for the top value, which means this is the mass number. This is the second part of this answer. Now we got to go below. 92 is down below. And down here, it's 0 and 36. Well, that's 36, but it needs to equal 92. So 92 minus 36 gives me 56. So if I look up 56, that is element barium. So my answer should be barium-139. All right, question 15. What is the molar mass? So we're just going to add these things up. 39 times 2 for the kryptons. For the iridium, I got no clue. Iridium is 192, and you should be using sig figs, but this is just so that I can get some quick answers for you so you could find your mistakes. 39 times 2 plus 192 plus 6 times 35.5, and you get 483 roughly. Make sure you're using units. Make sure that you are using sig figs in your answer. All right, moving on. Question number 16. So in question 16, we are asked to make some conversions. We are starting with 10 grams of aluminum. That's right here, a 10-gram sample of aluminum. And they want us to convert it into moles. To go from grams to moles, we will divide. We will divide by the weight of aluminum, which is 26.98 off a periodic table somewhere. So 10 divided by 26.98 gives you 0.37 something, 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 and this would be grams. Now it says, I'm sorry, this is moles. These are moles. But now it says for you to convert that, or to take the same 10 grams, convert it into atoms. So to do that, we will multiply by Avogadro's number. 6 times 2 to the 23rd, 6.02 times 10 to the 23rd, and you get 2.231 times 10 to the 23rd atoms. Make sure you have sig figs. Make sure you have units on all of your mathematically related answers. All right, now we are dealing with barium. This is the hardest one for many folks here. Barium undergoes a fission. So barium-140, 56 undergoes a fission. Oh, what kind of a fission? I can't even see it right now. Hold on. A beta fission, meaning it's going to produce a beta particle, 0, -1. And so what that means is that you've got a 140 up top, because 140 plus 0 equals 140. But over here, I would have to increase it to 57. And so my answer becomes lanthanum. Lanthanum 140 would be my answer, because 57 minus 1 equals 56, which is what it is on the left side. Then it says that this material here, this lanthanum 140, it's going to go through a spontaneous capture of an alpha particle. An alpha particle has a 4 and a 2. So what does it make now? Well, on top, it would make a 144. Down below, it would create a 59. So if we look at element 59, that's praseodymium 144. All right. Moving onward. So now I've got this equation. And I'm just going to simply substitute some of the values in for it. So I got 1.67 times 10 to the negative 24th, 1/2 that value. My velocity is squared, so it's 2.12 times 10 to the third squared equals 3/2 times the constant k, which is 1.38 times 10 to the negative 23. We are solving for temperature. The temperature is exorbitantly high. It is just absolutely crazy high, 181,000 degrees Celsius. I cut it off because of sig figs. After you do all the math, all you've got to do is simply plug those numbers into the equation, put it into your calculator. It's just a mathematical sequence. You need to be able to use your calculator to solve a complex equation such as that. All right, moving on. 19. Last questions, last set of questions. So in this one, again, it's asking you to understand that you have iodine 131. It is decaying by an alpha emission. So the 131 goes up here. It is making an alpha particle and something else. What else is it making? Well, that's what we have to figure out. We know that iodine is element number 53. So 53 minus 2, or in other words, 53 plus what? Well, it's going to be 51, which is antimony. On top, we need it to equal 131, so that is a 127. 127 plus 4 equals 131. So that is going to be my element that it needed to produce, and that's the way that you should write it out. All right, next, it's asking us, well, what is the time of the half-life? If it started at 100%, the half-life occurs when you hit 50% of your material left. What is the half-life? The half-life is 8 days. That is the end of our test. Thank you so much for your time. Hopefully you understand things a little bit better and you can now analyze what you didn't know, go back, and you can start adding some information that helps you prove that you have mastered the content. Thank you so much. I will talk to you again soon.